Dear students, if there are two lines, direction cosines of the first line are L1, M1, N1 and direction cosines of the second line are L2, M2, N2. Then angle between these two lines is given by cos theta is equal to L1, L2 plus M1, M2 plus N1, N2. This is the formula for finding out angle between two lines whose direction cosines are given to us. These two lines are perpendicular if theta is equal to 90 degree, and you know if theta is 90 then cos theta is 0. Cos theta is 0 means L1 L2 plus M1 M2 plus N1 N2 is equal to 0. And these two lines are parallel if L1 upon L2 is equal to M1 upon M2 is equal to N1 upon N2. This formula you have already studied in class 11. In terms of direction ratios, if A1, B1, C1 are direction ratios of the first line, A2, B2, C2 are the direction ratios of the second line. Then cos theta is given by A1, A2 plus B1, B2 plus C1, C2 upon under root of A1 square plus B1 square plus C1 square into under root of A2 square plus B2 square plus C2 square. Now lines are perpendicular. If again theta is 90, that means cos theta is 0. That means numerator A1, A2 plus B1, B2 plus C1, C2 is 0. And lines are parallel if A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. That is when direction ratios are proportional to each other. Let's take few simple examples. The first example is a line makes angles 45 degrees, 60 degrees, 60 degree with the positive direction of x-axis, y-axis and z-axis respectively. Find the direction cosines of the line. Now this line makes 45 degrees with x-axis. That means alpha is 45 degrees. Similarly, beta is 60 degree and gamma is also 60 degree. So therefore cos alpha is 1 upon root 2, cos beta is 1 upon 2 and cos gamma is also 1 upon 2. That means direction cosines of the line are given by 1 upon root 2, 1 upon 2 and 1 upon 2. Let's take one more example. Find direction cosines of a line which is equally inclined to the positive direction of the axis. Equally inclined means alpha, beta, gamma are all equal. Now because alpha is equal to beta is equal to gamma, therefore cos alpha, cos beta and cos gamma will be equal. That means L is equal to M is equal to N. And now we know the formula L square plus M square plus N square is equal to 1. So in place of M and N we write L. So therefore we have L square plus L square plus L square is equal to 1. That is 3L square is equal to 1. So therefore L is equal to 1 upon root 3. Why do we take positive sign? Because line is equivalent to the positive direction of axis. So we take only positive sign. L is equal to 1 upon root 3. And thereby M is also 1 by root 3 and N is also 1 by root 3. You can try these one or two exercises. PQRS are the points 632, 514, 3 minus 47 and 0, 2, 5 respectively. Find the projection of line PQ on line RS. Now in the last lecture I had told you the formula for finding the projection. We know the projection of a line AB on CD is given by x2 minus x1 into L plus y2 minus y1 into M plus z2 minus z1 into N. So you can make use of this formula and find out the projection of PQ on RS. In the next exercise you can try this. Prove that the points minus 2, 3, 5, 1, 2, 3 and 7, 0, minus 1 are collinear. Means we have to show that these 3 points lie in the same line. So one method is 3 points ABC are collinear if the direction cosines of AB and BC are in the same proportion. Means you can find out direction cosines of AB and direction cosines of BC. So you will see that they are in the same proportion. Second method can be by using section formula. You take the ratio lambda is to 1 and then you can try it. Right? You have done it 11th class. Third example. Show that the angle between the four diagonals of a rectangular parallelepiped whose edges are A, B, C are given by cos inverse of plus minus A square plus minus B square plus minus C square upon A square plus B square plus C square. So we are given a rectangular parallelepiped. So this is our rectangular parallelepiped and its edges are A, B and C. That means OA is equal to A, OB is equal to B and OC is equal to C. So we have to find out angle between its four diagonals. What are the four diagonals? First diagonal is O to G. O to G is first diagonal. Second diagonal A to E. AE is the second diagonal. Third diagonal D to C. DC is the third diagonal and B to F. BF is the fourth diagonal. Right? So we have to find out angle between these four diagonals. So first of all we shall find out we shall consider two diagonals and find out the angle between those two diagonals. Let us consider two diagonals as OG and AE. We will find out angle between these two diagonals. Now what are the direction ratios of OG? Coordinates of O are 0, 0, 0 and coordinates of G are A, B, C. So therefore direction ratios of OG are A minus 0, B minus 0, C minus 0. That is A, B, C. Similarly, direction ratios of AE. What are the coordinates of E? 0, B and C. And coordinates of A are A, 0, 0. So therefore direction ratios of AE are 0 minus A, B minus 0, C minus 0. That is minus A, B and C. So now we can find out angle between these two diagonals OG and AE by using the formula A1 A2 plus B1 B2 plus C1 C2 upon under root of A1 square plus B1 square plus C1 square into under root of A2 square plus B2 square plus C2 square. So here A1, B1, C1 are A, B and C, A2, B2, C2 are minus A, B and C. So put these values in the formula and we will get it as minus A square plus B square plus C square upon A square plus B square plus C square. So this is angle between OG and AE. Similarly, if we consider other pairs of diagonals, we will get that angle between any two diagonals of a rectangular parallelepiped is given by this one. Cos inverse of plus minus A square plus minus B square plus minus C square upon A square plus B square plus C square. Now you can try this one. Find the angle between the diagonals of a cube. What is the difference between parallelepiped and cube? In parallelepiped you have three sides A, B and C. Length is A, B and C. Whereas in the cube all the sides are equal. Means you take OA as A, OB also as A and OC also as A. Then you can obtain angle between diagonals of a cube. Next exercise. Prove that the line, next example. Prove that the line joining the points A, coordinates of A are 1, 2, 3, B, minus 1, minus 2, minus 3 is perpendicular to the line joining the points C and D. Means we have to show that line AB is perpendicular to line CD. So for that we will find out direction ratios of AB and direction ratios of CD. Direction ratios of AB, we make use of the formula x2 minus x1, y2 minus y1, z2 minus z1. So we get direction ratios of AB as minus 1, minus 1, minus 2, minus 2, minus 3, minus 3. That is minus 2, minus 4, minus 6. Divided by minus 2, we get direction ratios of AB as 1, 2, 3. Similarly, direction ratios of CD are 3 minus minus 2, 3 minus 1 and 2 minus 5. That is 5, 2 and minus 3. Now make use of this one formula A1 A2 plus B1 B1 B2 plus C1 C2. So what is A1 A2 plus B1 B2 plus C1 C2? 1 into 5 plus 2 into 2 plus 3 into minus 3. So we get it as 0. That means A1 A2 plus B1 B2 plus C1 C2 is 0. So therefore line AB is perpendicular to line CD. Now you can try this problem. Find the direction cosines of the lines which are given by the equation L plus M plus N is equal to 0 and Mn minus 2 NL minus 2 LM is equal to 0. So if you want to solve this problem, you can go ahead like this example. Prove that the lines whose direction cosines are given by the equations AL plus BM plus CN is equal to 0, UL square plus VM square plus WN square is 0 are perpendicular if A square into V plus W plus B square into W plus U plus C square into U plus V is equal to 0. And the lines are parallel if A square upon U plus B square upon V plus C square upon W is 0. So we have to show that these lines given by these two equations are perpendicular if this condition is satisfied and are parallel if this condition is satisfied. So for this we eliminate say n. So find out the value of n from here. N is minus of AL plus BM upon C. Now put this value of n in this equation, second one. UL square plus VM square plus WN square is equal to 0. So in place of n, we substitute this minus of AL plus BM upon C. Now if you simplify it, we get this equation A square W plus C square U into L upon M whole square plus twice ABW into L upon M plus B square W plus C square V is equal to 0. Now as you can see, this is a quadratic in L upon M. So suppose that L1, M1, N1, L2, M2, N2 be the direction cosines of the line, then L1 upon M1, L2 upon M2 are the roots of this equation because this is a quadratic in L upon M. Now we know that product of the roots L1 upon M1, L2 upon M2 is given by product of the roots which is C upon A. You know that you have already studied in 9th or 10th class, right? So product of the roots alpha into beta is C upon A. What is alpha plus beta? Alpha plus beta is minus B upon A. So product of the root C upon A, that means B square W plus C square V upon A square W plus C square U. That means L1 L2 upon this term B square W plus C square V is equal to M1 M2 upon this one C square U plus A square W. And by symmetry you can write it as N1 N2 upon A square V plus B square U. How do we write it? See, here we have B square, C square, what should be here? A square, W, U, V, C square, A square, B square, V, W, U. So suppose this is equal to lambda. So lines are perpendicular if L1 L2 plus M1 M2 plus N1 N2 is 0. What is L1 L2? L1 L2 is lambda into this term. So put the values lambda into B square W plus C square V plus lambda into this term and plus lambda N1 N2 is lambda into A square V plus B square U is equal to 0. So divide by lambda throughout and simplify, we get A square into V plus W plus B square into W plus U plus C square into U plus V is equal to 0. Now lines are parallel if L1 upon L2 is equal to M1 upon M2. That is L1 upon M1 is equal to L2 upon M2. Right? This was the condition for perpendicularity, and for lines to be parallel, this is the condition. Now that means the roots are equal. Now you know that in a quadratic equation ax square by bx plus c is equal to 0. Roots are equal if b square minus 4ac is 0. So therefore, because roots of 1, where is 1? This is equation number 1. So what is A, capital A here? Capital A is this one. Capital B is 2ABW and capital C is B square W plus C square V. So we make use of B square minus 4AC is equal to 0. Put the values of A, B and C. Divide throughout by 4 and simplify it. And divide it by C square into UVW. So we get A square upon U plus B square upon V plus C square upon W is equal to 0. So this was to be proved. Okay. Thank you so much.